Good afternoon, everyone. My name is Mansoor Arora from Lepton Software Solutions, and we welcome you all for today's webinar on how to leverage Google Maps for network plan and build. Our speaker for the day is Mr. Shyam Devi Reddy. Mr. Shyam is the Director of Product Network Access at Lepton Software, responsible for product management, solutioning, and pre-sales. Mr. Shyam has 20 years of management consulting and pre-sales experience in telecom and geospatial industry, cutting across multiple geographies, that is North America, Europe, Middle East, and India. The session will be for 30 minutes with a Q&A session at the end of the presentation. I would request you all to kindly type your questions and queries in the Q&A window, and we will take them at the end of the presentation. Now, I would request Mr. Shyam to take the session forward with the presentation on the topic of the day. Mr. Shyam.
Right, thanks for that, Mansoor. I'm also joined by my colleague Jatin Taneja, who is our resident expert on Google Maps. Today's topic is to basically discuss about Google Maps and how to leverage that for telecom network plan and build. Right. What I'm showing right now is a common telecom architecture, right from the central office to the customer locations, and several things in between, the civils and the cables, ducts, the hubs and terminals and splitters. All of us who are into telecom industry and doing the planning and designing activity in telecom, very familiar with all these aspects of telecom entities. Right? However, what's common among all of them is they're all at a particular location. Of course, they are the key elements that actually allow us to provide service to a customer. However, each of them are at a particular location. So not only knowing the properties of a particular network element is important from inventory point of view, location of where they are, how they're connected, how can I reach a customer, what is the path that I can use, where the customer is located, what is the route that I can use to provide the service to the customer. So all of them become very critical or important decisions a planner or a designer has to take into consideration before a plan or design is put up together. A bunch of customers at a particular location helps us to understand the demand in a neighborhood, and that demand gets aggregated to the nearest aggregation node. And we got to size our electronics and the cables for the demand. Vice versa, all the way back to the distribution and transmission cables as well. So the point here is, while the capacity requirements are important, location plays a critical role in taking that particular call of what should be the sizing of an element or a cable. And knowing where the customers are and how we can route our networks to them also becomes a very important priority. To help us do that, what we traditionally have been doing all the time is we use maps, or both either digital or paper maps. So in the current context of a digital world, a digital map becomes very, very relevant. So what's a digital map? Or in other words, in the industry, it is called Geographic Information System, or GIS. What is it? It's basically a layered architecture of modeling our real world. In our real world, we got public infrastructure facilities like roads, public use areas, and the land use classifications like industrial land or commercial activities or residential homes, and the locations of these customers, whether they are enterprise or residential. So customers are located at a particular area or a location, and they can be reached using public infrastructure, and that is the real world. And on top of the public infrastructure, we lay our telecom infrastructure too. So we use things like roads to route our ducts and cables and put our poles or any other necessary telecom infrastructure elements. For that, we always use public infrastructure. So describing the world in a layered architecture, like terrains and streets and where the customers are, and then our networks as well on top of the physical world, is what we could call as a GIS system. In the context of telecom, we also not only put our physical networks, we try to understand capacity from point A to point Z. From a marketing point of view, we try to understand revenue potential and the jurisdictions, the circles, and the boundaries and all that stuff. And if there are some events like faults happening around, and we want to understand where the faults happen, and then correlate that where information to what is the element that's causing the fault, and what is the impact of a particular fiber cut downstream or upstream. And also optimize our field force when they're actually deploying or operating in the real world. So all of that contextual information is what we derive using a map-centric system. And which is why maps or GIS becomes very, very relevant detail planning and design, as well as operations. Right, when you say GIS, what is GIS? We described what GIS is in the previous slide. But in order to build a GIS, what is typically required? On the extreme right-hand corner, there's some paper maps. Paper maps have been there for ages, and we have seen it all through these years. Even now, we use in most of our daily use. So paper maps is a good source to start with to build a GIS data set. From paper maps, we've started describing or documenting our world in a CAD or Visio type of diagrams, like floor plans of buildings. So that could be one of the input. And using the latest technologies like GPS, satellite connections to a GPS, finding out the lat long and Z elevation information, that is an input that can be fed into a GIS database. And also we use satellite imagery, again, using modern technologies, to capture the Earth's surface using a satellite picture or aerial imagery. That also is an input or can be an input to build a GIS database. All of these different sources help us provide or create the databases or data sets that we typically want to use in understanding the market or understanding where the customer is and how to connect them. Now, while we realize that this is an important information, important data source, there are a lot of challenges we face when we want to use the GIS as a base for our planning activities or design activities. These challenges with the data sets are primarily centered around the quality of the data sets. In order to route a particular cable or a duct, we've got to know the exact path that can be used. What is the width of the road and which side of the road that we want to use, or things like that. So the precision of the quality of data sets, the depth of data sets play a very important role. And most often than not, the data sets that are available in the market that allow you to buy digital map data sets, they are not often very accurate or not often very, very recent or current, so to say. Also, if a telecom company decided to build the data set themselves or create the land base themselves, it requires a lot of effort and time, and it requires a lot of manpower as well to build the data set. So it primarily requires an army of people with the processes and with all the necessary tools to keep on building that particular data set. And also what happens is once you buy a data set from a provider, for example, there's a provider who's able to provide the data set out of the box. You just take the or buy the particular data set or take it as a service. What's not constant in the world is the world is always changing. The cities are growing, they're ever growing, they become bigger and bigger and bigger, irrespective of which part of the world that we live in. There's a lot of rural to urban migration happening. And a lot of land use keeps on changing all the time. So there's a constant change in the geography, in the land use patterns, and the growth of towns and cities and villages. So as these places grow, we also have people coming in, which means that we have got customers, and To reach the customers, we got to have the latest data set to know exactly where the customer is and how I can reach the customer. And that was a challenge because, every few months or every few years, you got to keep on updating your GIS data sets uh, to know the latest truth of what's happening in the real world. And the final challenge here is it is not a core operation of telco. If telco operator decides to manage the creation of land-based data sets, it is not the core operations of telco. Rather, the telco focus on providing service and providing quality of service, and then identify what services are required in the market. But whereas a land-based creation or a GIS dataset creation, uh, which requires a lot of time and effort and money, an army of people to build, is not a core operation of telco. So that's a challenge as well to manage. So these are several challenges that we typically have seen or continue to see in the industry for a good quality GIS dataset. Now, there's one platform out there that tries to address these challenges, not only for telecoms, but it has got a broader context. But the point is, whatever this solution is doing, it is very, very much relevant to telecom and very much relevant to the challenges that we just spoke about. And this is Google Maps platform. Google Maps has become part of our lives. The user experience of using a Google Map, whether it's on a handheld device or whether it's a tab or a desktop, uh, or any kind of device, digital device, the platform is available, and not just the different devices that you can use to access Google Maps, the richness of the data sets and the satellite imageries and street view maps. It's very rich in terms of the data that it provides, and also most often, it is current, and the depth of information it provides is unparalleled. So, because of all the advantages the Google Maps provide, Lepton has made a conscious decision to use Google Maps as the base for our network access for a portfolio that is addressing the plan and build use cases. So apart from the maps and the satellite imagery and the street views, Google Maps platform is a lot more than that. It's a big platform in itself, and it provides lots of web services which are at the bottom. So we can use Google Maps for geocoding. We can use it to address the places and search for places. We can use it to understand directions between 2 points or more than 2 points. We can calculate distances from a point or one point to the point using the nearest neighbor algorithms and things like that. We can identify how things are connected by using road network. You can also use time zone API, like what a particular area has been a few years ago to what it is now. Not only it's a 2D information as lat long, it also has got the Z information. So it has got elevation API as well. So you want to identify what is the height of a particular location. That also is provided along with the Google Maps platform. And of course, geolocations. So all of these particular capabilities, apart from the maps itself, there are a lot of capabilities it provides, and these capabilities are very, very relevant to telecom use cases. And I will touch upon these use cases and how these particular APIs are relevant in subsequent slides. It's a rich platform providing maps, providing satellite imageries, providing street views, as well as a lot of feature capabilities which are exposed as an API. On the web, it has got JavaScript and Street View APIs and static maps that can be used. And on an Android or iOS device, we can use the API to identify the places and also to do a lot of routings as well. So Lepton has used all these capabilities that Google Maps platform provides to address the needs of a telecom plan and build. With the platform that Google provides, it brings us a transformational opportunities for telecom as well as several other industries globally. Anything that requires location to conduct their business, Google Maps platform is ideal choice for that. Because of the capabilities it comes with and unparalleled coverage it has got, we can create new business models. We can understand the ROIs, and increase efficiency of the field force who are in the field doing operations like fiber restoration or doing splittering activity or rollout activities. And of course, the user experience is a very important aspect of or important driver of Google. The response times that Google provides when you're doing searching for places, or doing something on a map, trying to understand how things are connected and what is the route to reach a particular customer. The power of Google to respond for every such query and at a very fast pace helps the user experience tremendously and improve the productivity as well. Looking at what the platform is, the depth of the platform, starting from the bottom left corner, every one of our searches that are done in Google platform are location based. And since the map platform is democratized and it has reached every person's handheld device, even the operators, even the engineers and the planners within telecom, they can use the power of Google to get to things that they're looking for. Also, the platform provides about 200 plus countries, maps for 200 plus countries and territories. Again, that's one single platform. So our solution also is scaled accordingly. So our solution can fit into multiple countries at the same time. And Google Maps comes bundled along with it. And two by third of the world is covered by satellite imagery. I remember during my college days, a couple of decades ago, about 20 years ago, getting hold of a satellite image or getting hold of an aerial photograph was a very, very difficult thing. Even if you get hold of one thing, um, it's probably outdated. It's maybe 5 years old, 4 years old. And that's when all the spot images and all those different imageries start coming into the world. But having a platform that can provide you the satellite imagery with almost the latest image for two-thirds of the world, it's amazing. And not only can planners use maps to do the routing, they can switch over to the imagery and then see the reality and a photorealistic view. Everybody nowadays uses navigation to reach place to place. So there's a lot of transits being done on a day-to-day basis. And there are directions for 199 countries, so um, you can pick up a customer and say, how do we reach the customer from a particular location? Directions are provided using the routing algorithms. And there are millions and millions of applications of websites that are built on top of it. So not only we can use it for plan and build, but if you have the platform, if you have your network that is on top of Google's platform, you can also help build more applications, more web apps that can be used by the organization, whether it's for sales and marketing or whether it is for customer care or anybody who can benefit by using a map. And it has been proven that it adds a lot of value to the bottom line. This 31% plus increased reporting value, which translates to about like $100,000 by using Google Maps. Again, that is variable depending on the scale of the business and the usage of the platform itself. There are a lot of efficiency improvements just because of the search capabilities and the response times and uniformity of the experience across the devices, whether you're accessing the network records and maps on a mobile device or a desktop, the uniformity of the experience helps a lot in efficiency. Of course, all the APIs and all those things, the rich APIs that helps do things much faster than what used to be. Many business, they start with a use case like plan and build, and then they start expanding the use cases to some other things in the ecosystem. That's what we have seen with our customers as well. And there are tangible business improvements that we have seen with productivity as well as customer satisfaction. So getting into the use cases, the first use case is planner. So what is a planner? The planner, again, it's a solution from Lepton in Network Access Suite. When you have a lot of customers and you want to connect all of them, we do aggregate the customers based on the splitter capacity, and then we automate the whole plan creation using all the engineering parameters. And what we use in Google Maps to achieve this, we use the routing algorithms, we use the shortest path, we use the nearest neighborhood algorithms to do the aggregation and things like that. And the APIs that we use from Google's platform is roads and the routes traveled, directions, of course, the distance matrix to find out what is the distance from customer to the nearest splitter. Of course, dynamic map, loading the maps all the time. Place search, you can definitely do place search. Elevation too, and geocoding. So we use all these particular features and functionality of the Google Map platform to achieve an automated plan using a minimal input like customer location, the splitter demand, fiber sizing, and the OLT. Everything is done in a few minutes, which typically used to take days. So that is the power of automating using the Google Maps platform underneath. Inventory is basically the web-based platform where telecom operators inventory all their civilian fiber networks, and of course all the connectivity and how the ports are connected to the fiber strands, spliced and splitted and reaching the customer. So all of that inventory at the civil level, fiber level, and the physical connectivity level is documented in the inventory solution. In inventory solution 2, we use visualization, we use search, routing, geocoding algorithms, Google Maps platform, and of course we use APIs and directions, dynamic map, place search, and elevation. Feasibility is another important application. In feasibility, what we do is we basically try to understand if a customer is feasible based on a particular location. It understands, if there's a network near to a customer location, and if not, like, what does it take to connect the customer, and what would it cost? What is the path that can be used to connect the customer? So all of that activities happen in feasibility. Again, we're using routing algorithms, shortest path to see what is the shortest path to connect customer from a particular tapping point. Of course, visualization, searching, and geocoding algorithms. And the APIs that we use are directions API, distance matrix to calculate the distances, dynamic map to show the visualization, place search, searching where a particular customer is, and we can also use autocomplete if you're searching for a business or address or something that's already there in Google Maps UIs, geocoding. Tracking. We help our customers in their operations for fiber restorations or splicing activity or any O&M activities or even patrolling activities. So all those different field operations, we support our customers with our solution called Track. And Track helps operators to provide the dispatch or understand the path a particular operator, a particular field personnel should be taking, or go to a particular location using a route. So all those typical activities are fulfilled by the Track solution. And here too, we use a lot of APIs from Google. Roads and route traveled API, nearest road API, dynamic maps, place search, and place search autocomplete APIs. And all these APIs enable us to provide features and functionality to address the tracking use cases. So in summary, the whole purpose of this webinar is to emphasize the point that there's a ready-made platform out there that can be leveraged and used to kickstart your engineering journey, doing your planning activity or operation activities. And trying to self-manage a GIS data creation, the data sets, and hosting them and serving the data, that in a fast-changing urban rural geography is quite a burden, and it requires a lot of time, effort, and manpower to do that, which can be counterproductive for a business that is whose core is not GIS dataset creation. And the platform from Google provides a comprehensive datasets, comprehensive platform with all the APIs, accuracy, and usability, with a modern web platform that works seamlessly across the digital devices, whether it's desktop, web, or mobile, in an enterprise. Thank you very much for your time. We are almost topping the half hour. We're ready to take questions now. Manso, can you help with the questions, please, if there are any?
Thank you, Shyam sir, for the insightful presentation. We would request you all now to type in your questions and queries in the Q&A window so that Mr. Shyam or our Google Maps expert, Mr. Jatin, can answer them. I would also request you to kindly fill in the feedback form shared in the link in the chat window. We would appreciate your suggestions so that we can improve our upcoming webinars. We have one question from Kavalpreet, that is, can we have the database for commercial buildings with lat long?
Jatin, I think you can take the question. Right. Let me try to answer that while Jatin is trying to speak up. So the platform comes with all the different commercial buildings and the POIs in this solution, right? So access to this particular POIs and commercial buildings is readily available. And in case there are some particular ones that you are interested specifically, our solution, network access solution, can help you do the lat longs for those particular buildings. We can definitely do that for you.
Next question that we have is what is the accuracy of the elevation?
So Google does not provide any quantification about the accuracy of elevation data. This is about, you provide lat long as an input to the elevation API, and it tells you from sea level it is at a height of, let's say, X meters or Y meters, but there is no quantification about the accuracy. Yeah. Next question, I would want to take up that is, can we have database for commercial buildings with lat long? Yes, in the platform, in the network access platform, which uses Google Maps at the backend, we have Places API from Google Maps, and through network access platform, you can get data of commercial buildings. And to be precise, Google Maps Places API does not provide, you know, straight away as such, the data that you're looking for, you will have to specify the category for the kind of data you are looking for the point of interest. It could be a restaurant, it could be a store, it could be, any commercial building. But then, yes, this is, data with Google is very, very comprehensive and can be provided. So next question is, do you provide your web/mobile app as a service or SDK that we can integrate with our app? Shyam, if you could answer this.
So the network access platform, we provide the API, and it's fully documented API. So for the web, absolutely, you've got the API, and you can use the API to stitch your own apps. The mobile app are very pointed in nature. They are built to a specific use case. So what I would suggest is, if you have the network access platform, you can use the API that comes along with the web, and you can stitch your own web mobile application. Whereas for the mobile application, we ourselves are going to provide a pointed solution. Next one, Jatin.
Next question is from Kavalpreet. He says he needs data of POIs for North region. So Kavalpreet, yes, it can be done. You can drop in with your exact queries. You can drop an email and then I can take it up in detail. As such, saying North, let's say North India, if I assume that's what you're talking about, that's very open-ended statement. That's a and we need to be precise. And there is a way how APIs are called, and through the network access platform, you can call the APIs in a particular manner, which will make sure that yes, we are getting the precise results. Yeah.
Right, very good. Are there any more questions? Are there any more questions, Mansur?
The recording of the sessions we'll be sending across to you on your email, and past webinars recording you can check it on our YouTube channel, that is Lepton Software. You will get the past webinars recording. Any other questions apart from this? I think so there was an technical error in between while we were answering Mr. Nikhil's question. He said there was no voice, but after that I think so Jatin has cleared the question. So did you get the answer, Mr. Nikhil, if you're there? Okay. Any other questions from the attendees which our technical team can help you and clear it out from this session? You can also write to us at the email ID that is provided in the presentation, and I'm also typing that email ID over here. Shamsa, we'll wait for a minute or so if anybody has a question, so we will just take that up, or else then we can move forward and close the session.
Sure.
Also, I would request you to kindly fill up the feedback form so that we can improve our upcoming webinars and make it more engaging for all of you. I'm forwarding the link for that as well. Okay, I think there are no more questions that are coming in. So I would like to thank you, Mr. Shyam and Jatin, for providing answers to all the queries of our guests. I would like to also thank the audience for today. We will be sharing the recording as told earlier for the session with you over the email for your future reference. Looking forward to your attendance on our next network access webinar. Thank you and have a great day ahead. Goodbye.